Alright, so if we look at this first one, it has a GCF. What do they have in common?
X squared.
X squared, yeah. Now, we're going to take that out, and we're going to think about this. Because when I factor something out, I'm writing it as a product, which means I'm multiplying. And when I multiply variables, I add their exponents. So if this is a 2, what does this have to be to make 6? A 4. And what does this need to be?
A 2.
A 2. Okay. Now, the reason this is fun is because even though it is not a quadratic, it's in quadratic form. Because this x to the 4th is really x squared being squared. Okay? So this is really quadratic form, though it's not a quadratic. So if this is x to the 4th, I can put an x squared right here and an x squared right there. You see it? Okay. And then we ask ourselves, what can we multiply to get 49 that we can add to
Negative
the
seven. Negative 7, negative 7.
Negative 7 and negative 7, and I love it, Sam. That is exactly how we would write it. And this is going to become critical later on. When we have the same binomial listed twice, we would write it as a power. So some of you may have seen it right here and gone, Miss Willoughby, that is a perfect square trinomial, and we should write it as a binomial squared. And you jump straight to this line.
Well.
And some of you will write it like this before you write it like that.
Oh,
and I'm okay with both of those. I'm okay with that. Okay, so what we're hunting for, what we're looking for, are things that we can factor like quadratics, even though they may not be actual quadratics. We can think about them being a quadratic form. Okay, so this one. Is there a GCF?
Yes.
Yes. What is it?
X.
X to the 5th.
Oh, it's X to the 5th. Oh, yeah. Well, I thought we were multiplying. I don't know why.
Okay. Now, if this is 5, what is this so that it makes 13?
8.
8. If this is 9, what does this have to be? 4. Okay. Once again, it's not a quadratic. But can I think about it as quadratic form? X to the 8 is like x to the 4th squared. Okay, so this would factor to x to the 4th and x to the 4th and negative 16 and negative 16 and negative 15. That's going to be a 1 and a negative 16. But we're not done.
Wait.
What?
No.
What do you see?
They're all
This is the difference of squares. So take it a step further.
Oh, jeez.
Thought I had the answer. I had it.
Where are we?
So they have like 4 of them?
So if we move
Yeah, you can like look at this.
Quartic.
This is my cake.
Did you know that
Okay, so most of you went here. And did you notice this one?
Oh, wow.
Yes.
Wait, what?
And there's another
This
one.
one.
It's like a.
Yes.
Oh, I didn't realize.
It's like Inception. There's just so many of them.
This will be you, right? This is so much fun.
Thank you, Ainsley. I would agree. Okay.
What is this? Like good old time.
All right. So now we are finally completely factored over the set of integers. So whenever we have a difference of squares, it continues to factor. A sum of squares, no. But a difference of squares, yes. Yes, Rob.
Does it end up with that many zeros?
Where?
It could have,
Whoa.
but it doesn't.
Triple it does.
But we'll talk about what it has really soon. But I'm excited that you're tying the two together. Yes, Jack?
So you wouldn't
This would get you some credit. But like if this problem were worth 8 points, to right here might get you 3. Maybe 4. Depends on how I make my rubric that day. Yeah, probably 4. So I'd do 2 points here, 2 points here, 2 points here, 2 points there. Yeah.
So wait, isn't it 8?
So this is the answer right here. This is completely factored over the set of integers. Okay? See, these are fun.
Yeah.
All right, now, this is 4 terms, and I can't make it quadratic. So I can't factor it in quadratic form. But because it's 4 terms, this is where you could try 4-term grouping. Now, I'm going slow. I'm going slow. I'm going slow. All right. If we look at the first 2 terms, we look at them and go, do they have anything in common?
X squared. X squared.
They have an x squared in common. So if I were to factor out that x squared, it leaves me with 2x plus 1.
Oh yeah.
Now, if this problem will factor with 4-term grouping, then these two, when I factor something out, I will be left with 2x plus 1. If it won't factor by grouping, I won't be able to make that happen. So, can I factor something out?
Yes. Negative 36.
Okay, now this is where I need you to make sure you understand this concept. Do you guys see that these two are a product? And these two are a product. So I have one term here and another one here. Do y'all see it? And they're separated by a minus. Do these two things have anything in common?
Which, oh.
2x and minus plus 1.
Yes, they have that binomial 2x plus 1 in common, don't they?
And then the next parentheses you will put.
And so
I'm
when
gonna
I
cross
pull
that
this out,
Oh, you get X squared minus
if I factor this out, what am I left with?
X squared
squared
minus
minus
36.
X squared minus 36.
That's not bad. I mean, if it's only if
Now,
it's
Think the.
Am I completely factored
because
over the
X
set of
squared minus
integers?
36 is
Yeah, Julian.
So it's x plus 6, x minus 6.
It is! You got it! You got it! Isn't this awesome?
This is just like.
Oh, that's a beautiful problem.
That's nice.
No, are all of them or it's just
Oh, they're all fun.
or it's just the beginning beautiful?
They're all a little fun.
Okay.
Okay, you try.
They're all fun.
You try this one. This one's
Obviously,
not as
Can
fun.
you teach this?
That is always step 1, Zimmy. You just warmed my heart. Step 1 is always GCF.
Oh, Jesus.
No.
That
That's not good. Whoops.
Okay, now, if you fail to see it, and I do sometimes too, you can catch it down here at the end. Do you see it? Okay, so if you've already done it the other way, you can catch it at the end.
My wrist is slowly acting back. I can't feel my wrist. I have too small of a low cut, and I'm kind of mad. It's too small. It's a medium. This one's a medium, but it doesn't hurt. Look at that, it's leaving imprints.
Then you shouldn't wear it.
It's fine now.
No, get them out there. That's it.
No, there's not.
What about?
But.
Can we open this up? Alright, I'm done. Wait. Yeah, I'm done. Okay, my turn. Wait. Yeah, I'm done. Alright.
Yo.
Alright, let's see.
Okay, yeah, I think I did, yeah. I did it once. I did it.
I did.
Only like it's March Madness.
I did. I haven't even been in this class.
Awesome.
That's not wait.
That's the answer.
Wait. Wait a minute. Wait a minute. What?
I just learned this like for the last question. Let's go.
Oh.
I did it right. I got it right. Let's square this, alright?
Now this one's not quite as fun because this is not a difference of squares, so it doesn't keep factoring, but it's alright.
It's fun.
Oh, okay. I see it.
Alright, so basically, have you noticed today we are factoring higher degree polynomial expressions?
Yes. Yes.
Okay, and we've talked about two different approaches. One, when they're in quadratic form. Two, when we use four-term grouping. Now, our third approach today is going to be when you see cubes. Now, both a sum and a difference of cubes will factor. Now, with squares, only a difference of squares will factor. But with cubes, we can factor both a sum and a difference. And I'm going to show you how. Now, this is a process that we just learned. I'm going to prove to you that it works. And I'm not going to make you write down all the work that proves it works. Okay, so this is a sum of cubes. So what is being cubed? What is being cubed? What is being cubed here? A. What is being cubed here? B. Okay, now since this is a sum, our signs will go plus, minus, plus. It's a sum, so it starts with plus. Plus, minus, plus. And then what we do is we take what was being cubed first and put it there, and what was being cubed second and put it there. So what was being cubed, what was being cubed. And then we square that first one. So it's A, so we square it. A squared. So we square the first one. I'm going to erase it from down here. Okay, then we do the product of these two. A times B, the product is AB. So we put the product of the two right here. And then we square the second one. So we get B squared, that's right. Now, when we multiply this binomial times this trinomial, it turns back into that. This looks like a lot and that looks like a little. But this is the factored form. We have it written as a product of its factors. So let me prove to you, if I were to distribute the A back through, I get A cubed minus A squared B plus AB squared. And then I distribute the B through, I get A squared B minus AB squared plus b to the third. Now, what happens? This cancels with this, and then this cancels with that, and I'm just left with an a cubed plus a b cubed. Is that what I started with?
See?
Okay, so that shows that it works. Now, am I going to ever make you do that step? No. But I wanted you to see it so you could believe it. All right. So, on this one, first of all, this only works if we have a sum of cubes. So we have to figure out, is this first term a perfect cube? Yes, it's just x being cubed. Is the second term a perfect cube? So what is being cubed here? 5. All right, so I always start with my signs. This is a sum, so it goes plus, minus, plus.
I have a question.
Yes,
If it's the minus first, would it be minus plus minus?
it's going to be minus, plus, plus.
Minus plus.
Yeah, I'll show you that in a second. So what was being cubed and what was being cubed goes here. And then we square the first one, the product of the two, and we square the last one.
The product of the, oh, no,
The product of the two
That's it.
terms. Yeah. And that's it.
This one is not complicated. There's actual steps in this one. Like steps.
Yes, sir.
Are problems like these on the quiz that we have to get 100 on?
No. Your quiz that you have to get 100 on is just factoring using trial and error.
So when do we take?
Maybe taking that test.
Probably Wednesday will be the first time I give you one.
As this one? As in like 2
Probably
days from
Wednesday.
now?
Yeah.
Oh, yeah.
Yeah.
What on with that?
So the first 2 times, I'll give you the opportunity to do it in class. And if for some reason you might need more opportunities,
I'll get
we
on
can
it.
utilize before school,
Right.
after school,
You ain't first
or
to
lunch and learn. Alright,
29th.
so this one's subtraction. So we're going to go minus, plus, plus. So every time there's only one negative. And because this is minus, this has to be minus. Because this is plus, this has to be plus. So plus goes plus, plus, and minus goes minus, plus. There's only one minus there. All right, so same idea. Exactly. What was being cubed? A. What was being cubed? B. Square the first, product of the two, square the last. So the only difference is the signs. The process is the same. So this is minus, so it's minus, plus. All right, so this is a little trickier to figure out, are they perfect cubes? Good. And it's going to be 3x to what power?
Squared.
Very good.
And 2y.
And then 2y. Yay! So here we put 3x squared. Here we put 2y.
And then square the first, so it'll be 3.
Okay, so we got to square this whole thing. So when you square the 3,
No, it'll be 9.
you get 9x to the 4th. Right.
You square the
And then the product of these two is going to be 6
6xy.
x squared y.
Squared y, yeah.
And then we square the last one,
4y squared.
4y
Why
squared.
do I just want to make
What's on that
that the
one?
coefficient wrong.
You can answer.
Okay, so you guys picked up the worksheet as you came in. That is your practice. Now, the top part is mainly what I just did. And the bottom part has more of that fun factoring. But always look for GCF first. Always.
She said fun fact. This is.
It is fun factoring.
The fun factory is the trial.
It's all fun, Joey.
Yeah, this is all fun.
The top